Hello everyone. Today we will discuss about the photoelectric effect and some observations and the experimental analysis of the photoelectric effect. So what is photoelectric effect? It is the phenomena of emission of electrons from a metal surface when light of suitable frequency falls on it. So it is the phenomena suitable frequency falls on it. Now, Hertz was a scientist who was performing an experiment for EM waves, for the production of EM waves. So, he was the first who observed the photoelectric effect in his experiment. So, let's draw a rough diagram for the Hertz experiment. We don't have to go into detail. For production of EM waves. So, what was he studying? He was using an induction coil here. And from here, this was connected to plates, and these were connected to spherical knobs, and then they had a wire having these spherical knobs. So when these sparks were produced here, and these sparks were transmitted to this detector, this wire and these spherical knobs were detector or receiver of EM waves, right? It was observed that when UV light is allowed to fall here on the emitter plates, the spark passed easily. So what was the observation here? The spark produced during EM waves experiment transmitted easily when UV light falls on the emitter of these EM waves. So what was the conclusion here? The conclusion was that UV light resulted in emission of some particles later called as electrons, which resulted in the passing of this discharge easily, this spark easily. So this resulted that light may increase or decrease the intensity, or it may produce a current, right? So then after, we had two more scientists, Halvach and Leonard. Halvach, he also did an experiment. You know about gold leaf electroscope, and in gold leaf electroscope we have gold leaves which whose divergence shows the amount of charge. Now this metal knob is connected to here to zinc sulfide plate, and he observed that when UV light falls on this zinc sulfide plate, so this was already negatively charged zinc sulfide plate, so that means there was already a divergence in this gold leaf electroscope. But they also observed that when UV light falls on it, then the divergence decreases. What does that mean? So when UV light falls, it resulted in decrease of divergence. So what is the conclusion here? The conclusion is that UV light resulted in emission of some materials, that is some particles, that is electrons. So if negative charge is moving from here, that means a corresponding positive charge will be produced here. Some positive charge will be there, which will nullify some of the negative charge here. So amount of negative charge will decrease, so the divergence will decrease. There will be less repulsion now. So I'll write this in the form of flowchart only. UV light releases electrons from zinc sulfide, right? So results some positive charge, so which nullifies some negative charge on zinc sulfide. Therefore, divergence decreases due to a decrease in charge, that is negative, on gold leaves. So this was another result which was given by Halvach. And then after, Leonard also observed this thing, again the same thing, similar thing. He also said that UV light exposure helps in increasing or decreasing the current in a circuit. So they were actually studying this photoelectric effect only by different experiments. So Halvach and Leonard performed these experiments, and on the basis of these experiments, then after a special experimental setup was prepared to study the photoelectric effect or the photoelectric emission, and that we will discuss now, on the basis of which there were some results which were drawn in the form of graphs and some laws were given later. So the experimental setup use a scale. So there was a tube, evacuated tube, where a window is left, transparent quartz window is left. So from there, UV light strikes on the emitter plate. This is the emitter plate. This is the collector plate. Collector plate, it has to collect the electrons. So that's why this is positively charged. And this is emitter plate. Which is actually negatively charged. And this setup is connected to a battery such that the polarity of the battery can be changed. This is the setup where this is high tension battery. This is the rheostat. This is the voltmeter, and these keys, these ends, if these are interchanged, suppose this is connected here and this is connected here, then the polarity of the battery can be reversed. So what did they do? They studied this experiment and they observed, there were observations on the basis of this experimental setup. They found a relation between photocurrent variation with collector plate voltage, frequency of incident light, and intensity of radiation. So V is collector plate potential, right? This is frequency of incident light, and intensity, I is the intensity of incident light. Small I am using here for photo current. So let's start discussing the observations. So the first observation is the variation of photocurrent with intensity of incident light. So how can we vary the intensity? So if the source is closer, more intensity. If source is farther, then less intensity. It is observed that when intensity is more, what happens is that the number of electrons falling per second, the number of photons falling per second increases. So if intensity increases, then number of photons falling per second increases. If number of photons falling per second increases, each photon gives rise to an electron, photoelectron, which is emitted from the metal surface. So this results in more electrons per second are emitted. What does that mean? This means photocurrent increases, right? So we can draw a graph showing this. So if we are plotting a graph with photocurrent on y-axis and intensity on x-axis, so this small I is current, photocurrent more specifically, and this is intensity of light. So there is a direct proportionality. So you can say that I and I are directly proportional. So here the graph is like this. We'll discuss the second observation on the next page. Second is the variation of photocurrent with collector plate potential. And this is also called as anode plate potential, right? So this graph is like this. We know that we have made an arrangement in this experimental setup to change the polarity of the battery. So here one concept of stopping potential and threshold frequency is also there, which I'll let you know. So this is the collector plate potential, which is positive on right side. Right? And this is the photocurrent. And here the polarity is reversed, then this is also collector plate potential in opposite direction. So the graph is drawn by keeping the frequency and the intensity constant. So for a particular graph, frequency and intensity is kept constant. So what kind of graph is obtained here? This kind of graph. This point is called as cutoff potential. I'll explain what it is. and this current where it is maximum, this is called as saturation current, because after this whatever voltage you will increase for the collector plate potential, the current will not change, because in this position all the electrons emitted from here reach the collector plate. So that's why saturation current is there. Now what is cutoff potential? Now if electrons are emitted from here and if we want to stop it, then we need to apply opposite negative potential from this side in order to stop this. So that minimum potential applied on collector to stop the electrons, this is called as cutoff potential or stopping potential. Other name for this cutoff potential is stopping potential, right? So this is cutoff potential. You can mark this cutoff potential by V naught. So we are checking that if the potential of opposite polarity is decreased, the current increases, and when this collector plate potential increases, it starts attracting more of the electrons, so that's why the current increases here. So you can say that for plus polarity of the potential, the current is proportional to voltage, right? So here when opposite potential increases, the current decreases. So for negative potential, current is inversely proportional to voltage. So whenever this value, this magnitude increases in opposite direction, then the current decreases. So this is one result. On the basis of this, sometimes some questions are asked in boards. So I am taking a case, special case A, where I am plotting this graph for two intensities and same frequency. So this is photocurrent, right? And here again collector plate potential positive and here minus, and for a particular intensity I1, I have plotted this plot here, I1 intensity and frequency nu, and for the second also this is I2 and frequency is kept same, right? So this kind of graph is observed. Here you can infer that I2 is greater than I1. Why? How can you say that? Because this saturation current is more, this saturation current is less, and current is proportional to the intensity. So for I1 the saturation current is less, so the intensity is less, right? And this is cutoff potential for both the graphs. So what is the result for this? That cutoff potential is independent of intensity. That means it remains same if intensities are changed, right? So this is one important result here. On the basis of this, many questions are asked in the board. I can take case B again. Now this case A is taken from here. Now case B, frequency 1 and frequency 2 are taken and intensity kept constant. So what will happen? these are very important graphs. You have conceptuals based on these. So again, this is photocurrent. I am not labeling again. So this is plus V, that is collector plate potential. This is minus V. Now I am drawing these for two different frequencies. So for a particular graph, the frequency and intensity is same. Now for the second graph, the frequency is varied, but the intensity is kept same and the frequency is varied. So for this, intensity is same but the frequency is varied. So you can say that here you are getting cutoff potential for first, and here you are getting the cutoff potential for second. And you can also mention that this is for graph, this is the graph for frequency 2, this is the graph for frequency 1. So what is the result which can be written from here? That frequency is directly proportional to cutoff potential. Right? So that means nu2 is greater in this graph as VO for second case, that is cutoff potential for second frequency, is greater than cutoff potential for the first frequency. Right? And what is cutoff potential? We'll write the definition. It is the minimum potential which must be minimum negative potential which must be applied at collector plate to stop the electrons from being ejected. Right? So we will write a few mathematical terms here. So whenever negative potential is applied here, that is minus V naught stopping potential, and this these electrons stop. So you can say the maximum kinetic energy is equal to the opposite energy gained when it is accelerated by stopping potential. So you can say half, this can also be written as E max, right? So half mv max square is equal to EV naught. So this is one relation which will be used in the numericals. So let's now define the stopping potential and threshold frequency. This definition has been asked many times. So what is stopping potential? The minimum negative potential applied at collector plate to stop the electrons, that is to stop the photo emission of the electrons. This is called as stopping potential. So that means, in other words, the minimum negative potential applied at collector plate to stop photocurrent. One and the same thing. If electrons flow stops, then the photocurrent also stops. What is threshold frequency? The minimum frequency of incident radiation for which the photo emission takes place. Right? Then we have one more concept which we'll be studying later, threshold wavelength concept. So this is the maximum wavelength below which the photoelectric emission takes place. The maximum wavelength below which the photo emission maximum wavelength of what? Of incident light, right? And the minimum frequency of incident radiation for which, or you can write above which, minimum है ना, so for which the photoelectric emission takes place, above which so it takes place. So that's all for this video. Thank you and have a nice day.